When we think about cloud technology, one of the things that generally doesn't spring to mind is the energy that we use to make it run. The data we all use simply goes somewhere and then comes back when we need it, and few of us ever stop to consider where it goes, or how it gets stored, or how it keeps going. From a purely individual basis, when you choose to listen to a tune or a podcast or make a purchase online or in person, we never think about the machinery running in the background, constantly devouring precious electrical energy to keep those bits flowing. But nothing comes without a price, and with computing power and cloud technology growing exponentially by the day, its power demands, just like those of coal, fuel, and nuclear, are already leaving a mark. So, what should we do about that? I'm Steve Prentice, and this is the Thales Security Sessions podcast. To help us understand the impact that cloud has on its own ecosystem, I have with me Margaret O'Toole, worldwide tech leader of sustainability at Amazon Web Services, and Patrick Fulop, Vice President, Cloud Operations at Thales Digital Identity and Security. So first, let me say what a pleasure it is to be working with both of you today.
Yeah, great to be here. Thanks for having me.
So thank you, Steve, for invitation, and it's great to contribute to this topic. I'm very passionate about this.
My intention here is to start with an understanding of the actual power demands and power consumption of cloud technologies, because it's not really common knowledge. Many of us have seen images of crypto mining farms where there are rows of CPUs churning away using an invisible power to create an invisible product, and for many of us, that's our first awareness of the fact that cloud technology is far more physical and elemental than its name suggests. So as a very basic question to start out with, why is the energy consumption of cloud actually an issue? And why is the environmental cost of cloud something we need to be concerned about?
Okay, that maybe I can help you there. It's all about demand. So if we come back a little bit in time to history, PC was invented 40 years ago, and it took almost 40 years to go from zero device, basically, at the time when it was created, to now something like 2 billion computer in this time frame. So let's say in the same time, we had in the last 20 years, we switched from zero smartphone to almost 7 billion smartphones today. So we see the acceleration going. And it's really exponential. And the next wave, which is coming, which has started, is IoT. IoT, from our estimations today, is something that could beat 30 million in the years to come. So we see that we have various waves of devices that are accumulating and are creating demand for the cloud. So the cloud is about providing not only the network power to be able to accommodate this demand, but also the data center. So data center basically is a big place where we have a big fridge where we put all the computers that are serving the demand. And this demand has accelerated vastly. So if we look at the stats, basically in the last 10 years, we have seen that the demand in terms of number of transactions has been multiplied by 8. That's figures that come from EA. How can we accommodate this increasing exponential demand and combine this with the cost for environment? So to produce a data center, we use generally carbon emission protocol, which is about separating the various kind of emissions. So we measure the way the various activities are producing emission of carbon in the atmosphere, and we classify them in 3 scopes. First one doesn't already exist in digital. That's all about the energy we directly consume and produce. We don't have that in digital. So in data center, it's mostly about scope 2, which is about the energy, electricity that we consume, which indirectly generates carbon emission. And this in digital represents something huge. It's about 1/3 of the total of the carbon emission that we consume overall. And this is really power hungry on the grid, so it has a direct impact, what we can measure, and can be significant in some countries. And then we have the largest scope, which is scope 3, which is not something that we have today a good estimation about that. We estimate it's at least 2/3 of the total. It's energy that has been consumed and transformed into carbon emission to build data center, to build the equipment in it, and to recycle them. So we see that all this big, huge demand, this explosion of demand generates an impact on all this capacity that we have to produce. The good news is that even if the demand has exploded by 8 in terms of demand of request to the data center, the energy usage has been quite stable because we have been incredibly efficient about this. But it shows that it's a rebound effect also. So it means that every time that we were able to do some benefit about the productivity of this capacity, we reuse that by new usage. So that's the bad side of this demand.
So the potential for inflation exists. And given the exponential growth in new technologies like AI, that rebound effect looks pretty imposing. Margaret, what is your perspective?
Yeah, I mean, a couple of things, right? So there's digital services and cloud in particular have become such an intertwined part of our lives that we've kind of forgotten about all of the things that happen behind the scenes. At AWS, we kind of think of this through this lens of a shared responsibility. And we usually talk about this kind of from the perspective of security, but it also applies here when we talk about kind of the environmental cost of operating anything in the cloud. So when we think about the shared responsibility of sustainability in cloud, we think about AWS has some level of responsibility to decarbonize its operations. We are responsible for running data centers effectively, efficiently, and responsibly. We're responsible for doing things like meeting the commitments we've made around net zero, meeting the commitments we've made around renewable energy, all of these kinds of things. But there's also, to Patrick's point, this usage component. Um, Cloud is very efficient, but it's intentionally designed to be elastic, and we want customers to be very mindful about how they consume cloud so that they're consuming just the least amount that they need in order to get the job done. And just because it's very easy to use and very elastic doesn't mean that we should be using it as if it has no cost at all. And so the other half of the shared responsibility model is, customers really need to optimize their workloads to use as little as possible in order to meet whatever outcome they're trying to go for, but doing that with the fact that there's obviously some environmental cost of doing anything. And if we're going to make something so integral to our lives, we should really have this efficiency mindset from the start.
Shared responsibility paints a picture of the responsible use of an elastic technology on the part of every consumer. And then we have to factor in the greenhouse gas protocol as the standard that everyone must comply with. It's like the two sides of a coin, both of them supporting a standard of best practices. So can we expand a little bit on the greenhouse gas protocol itself beyond Patrick's summary? How does it apply to physical data operations, and how do organizations ensure that their compliance is visible?
Yeah, so Patrick outlined kind of the major points of it. So the greenhouse gas protocol, obviously it's a pretty dense document, but the wide-ranging application here is that there's 3 scopes of emissions. Scope 1 emissions are direct emissions. If we can maybe think about a data center, just to kind of make this a little bit more concrete. Scope 1 emissions from a data center are usually coming from a backup generator. Now, that's obviously not running most of the time. That's not the primary power source for a data center. But Scope 1 emissions come from when there's like literal combustion, like an actual gas is being emitted. There are things that you can do to reduce Scope 1 emissions. So for instance, with data centers, obviously, if you're using a diesel generator, moving to other fuel types that have lower emissions is better. AWS, for instance, is using hydrogenated vegetable oil in some regions to reduce emissions associated with the Scope 1 emissions. Scope 2 emissions come from anything that is like energy that powers something else, so electricity usage, this kind of thing. The obvious lever that you have here is investments in renewable energy. And so investing in renewable energy obviously reduces your Scope 2 emissions, or the emissions associated with the energy produced to give you electricity to power the data centers. Obviously, there's been a lot more investment in renewable energy over the last couple of years, really accelerated in the last really a decade or so. And so now we see these major projects that are coming online to help facilitate the clean energy transition. And then the last scope of emissions, Scope 3, is what we say is kind of everything else. It's upstream and downstream emissions that come from the supply chain, they come from usage. Within a data center, you could think about this as being the emissions that are caused from extracting raw materials, processing them into hardware, and then also end of life. And so in order to reduce Scope 3 emissions, obviously you need to work a lot with suppliers to understand how you guys can work together. And then maybe just kind of from the AWS perspective, one of the things that we do is, because we're also working a lot on some custom hardware that we're obviously involved in the design of, designing it from the start so that it's easy to take it apart at the end of life, which makes the recycling process much easier and then obviously has a knock-on effect of reducing emissions as well as reducing waste.
Often when people think about cooling centers for data processing, they think first about water, which is also a significant natural resource, obviously, one that is getting scarce in certain parts of the world. So what do we need to know about water from a data perspective?
It's easy to forget about the water side of the equation, but data centers often use water for cooling. When we think about data centers in general, there's a heat component to it, and so needing lots of cooling agents in order to reduce the temperature so that the operations can continue safely. It's super important. There's some new stats out around kind of the heat that's required in particular for machine learning models and the chips that are underpinning that. And there can be up to 1,000 watts of power per chip more that will need to be liquid cooled. So that's a material increase, and we need to be really considerate about how we're using things to do cooling. And so having to balance what we call direct air cooling and liquid cooling so that we're being mindful of our water usage is also an important component of this. And so that's also why you'll see, like for instance, AWS has a goal to be water positive to kind of go alongside the decarbonization journey. We're going to talk today a lot about energy, which we should. It's a really important point, but I just want to make sure that we don't lose sight of the fact that there are other considerations here from an environmental perspective.
Organizations such as AWS are being very proactive in terms of ensuring that all three scopes are correctly overseen and managed, but there are many places in the world where, for numerous reasons, they may not be so interested in following these rules, and they may have their own economic or political reasons for doing things their own way. Is shared responsibility model something that can be well policed, especially internationally? Can we or should we keep an eye on this? Patrick, if I may start with you, just what are your thoughts with regards to how we can effectively police the power and resource demands of cloud and data on a global scale?
That's a great question, Steve. If we see what is more visible, like, for example, the boom of cryptocurrency and the boom of energy it requested, but we have to say it's quite speculative. And when we look at the cryptocurrency specifically, it was not regulated at all. The energy tax that they took has been tremendous. We have seen that for some years, it was as significant as the world in terms of data center used specifically for data mining. So we can see clearly this as a waste of resource outside of the financial benefit for the few users of this. In some countries, like, for example, Mongolia, that decided to ban crypto due to the strain on local grid. So in this domain, a very visible outburst, it's really up to each government to enable its policy. And that's what is very visible, but not very meaningful in long term.
So that takes care of crypto as an essentially unregulated consumer of power by its very design. But what about IT?
In my point of view, if we focus on the industry of IT, it's estimated yearly that we consume something like 200 terawatt hours per year. So it's huge. Huh? It's the size of half of all France electricity production of a year. So it's significant. That's the consumption for scope 2 of energy for data center. And there is a growing concern about the share of this energy spent for IT. But if we take a practical example, think about all the energy savings linked to GPS system about transportation in terms of gas saved. And as we avoid traffic jam, we are more encouraged to take the car. So that's a rebound effect linked to a benefit. So it's a complex issue. Huh? So my personal belief about your question, as I'm a concerned citizen, that of course IT will not save the world with this part of usage, but it can have an impact. And what I advocate is exactly what, like Margaret said, I believe in frugality in delivering your services.
So this is what you call Carbon FinOps? How does that work exactly?
It's not about the financial optimization as such, which is good for companies, but it's not good for the planet. What matters is really to be able to deliver the same service or better service with much lower usage of energy. So internally, if I can testify about what I've seen in Thales, my company, is that we have seen an evolution. We had already a good FinOps team, and this FinOps team was able to generate reports on a monthly basis for each application owner to show the cost over time. With some evolution to bring some rules of calculation about the carbon linked to the FinOps, we were able to transform it to Carbon FinOps.
Carbon FinOps as a best practice.
Yeah. So today we are able to show reports at all levels of the organization about how much cost it generates, how much carbon it consumes, and that's really attractive for the organization. Not all parts at the beginning, of course, but some people were pioneers in that, and it started to create critical mass. And now we start to show that to customers, and they like it. Notably, we are in a bid, answering a bid. It's good to have some data about this evaluation of the effort. So in general, I think that the regulation will come from the market. And the market, we see that our efforts and multiple label and certification are creating a space for differentiation. For example, Thales, my company, has committed to shareholders for a strong decrease of carbon emission versus pre-COVID time. So that's a strong commitment, which is backed by SBTi audit, so a science-based target audit. And it's included in our collective bonus. So it's really a way to influence the way we behave in this domain and to lead by example. As you said, it's a non-competitive challenge for the planet, and we are all sharing the same and unique atmosphere. So there is an incentive to share it, as we do right now, and to share our approach about this.
It appears then that both of your respective organizations, Thales and Amazon Web Services, and many others that are large players, have not only the wherewithal to enact a more responsible approach to resource management, but you also have perhaps the capacity to exert the kind of influence that can inspire other organizations to make it happen. So, Margaret, what are your thoughts about that?
If you're familiar with AWS, you guys are familiar with the well-architected framework, which is basically like way back in ye old days when cloud was new and people were like just kind of putting things up in cloud the same way they would have built on-prem. They found that maybe things didn't work as well as they had hoped. And so well-architected was kind of in response to this. It was, hey, these are best practices that we know are tried and true. We've learned this the hard way sometimes, and we've learned this from seeing customers do things. And so this has kind of become the standard of how we want to encourage customers to behave in ways that are most likely to build things that deliver on what they're trying to do. And so a couple of years ago, we started work on sustainability, and it was a very similar line of logic to what Patrick's talking about. It's how do we help give people a line of sight to the fact that there is an environmental impact to the work that they're doing on AWS specifically, and how do we give them best practices that encourage them to make good decisions and kind of have a rubric to grade themselves against. And so when we started doing this work a couple of years ago, we were really trying to think about, okay, well, what are low-hanging fruit optimizations and what does that look like? And we also had to have this pretty, I would say, like intense debate around how different is this kind of optimization from cost optimization, like materially. What's really the difference that we're going to drive in an organization? And how do they think about these two concepts working together? Because most optimizations that you make that reduce emissions reduce cost. And there's a nice synergy there, and that's a good thing. But the fundamental difference still is, and you can read this in the white paper for the well-architected sustainability pillar, is we want customers to understand their usage. What are you getting out of what you've provisioned on cloud? Not what you've used. What have you provisioned, and how much work are you getting out of it? And encouraging customers to think about things from a perspective of what is your resource consumed per unit of work done? Or resource provisioned per unit of work done, and helping customers think about this from a real efficiency perspective. You know, if we go back to previous times of industrial revolutions and think about, okay, well, we were able to make like X number of nails per this amount of steel, or we were able to do this much work and create this many cars, and it was this much energy. And we need to kind of make that metric possible for cloud as well. And the nice thing is we have a lot of telemetry. The difficult thing is this is a bit of a mind shift change from just looking at, a bill and saying, okay, well, we could use savings plans or reserved instances or spot, which are useful tools from a financial optimization perspective, but not necessarily going to drive down the actual resources provisioned metric, which we really want to get down, and to contextualize that against their actual usage, like how much valuable work gets done for what you've provisioned. And so that's really what we've tried to drive home in the well-architected pillar for sustainability and kind of all the work that's happened since we launched that and trying to help customers develop what we call like sustainable IT practices internally and develop the muscles that help make this part of their daily operations. And I think Patrick's organization is a great example of how this has worked like really in practice. But there's been a lot of customers that have adopted this in different ways to try to embed this culture internally.
And you have SUS Scanner, which helps as a tool in this regard. What does that do?
So SUS Scanner is basically the next step after the well-architected sustainability pillar. SUS Scanner will scan your CloudFormation templates and tell you if you have kind of adhered to best practices, if there are risks identified based on how you've adhered or not adhered to best practices in the well-architected pillar. But it's open source, right? So the idea is that people can use this as part of their normal CI/CD pipelines in order to kind of validate their operations against the best practices in the pillar.
Given the amount of energy and power we're talking about, and given the continued growth in demand and scope of IT projects, especially with AI, and despite the proactive procedures that AWS, Thales, and others have put in place to calculate essentially a return on the energy invested, despite all that, there are likely some countries or even areas within countries that may not want to play this responsibility game, maybe in the interest of short-term profits, political alliances, or maybe as an objection to what they see as excessive legislation. So let's play out the doomsday scenario. Let's say that we can't adequately police this kind of increasing power consumption. Are we looking at the potential for real-life blackouts, a strain on power grids around the world in the same way we're seeing landslides and flash floods in areas where land and infrastructure have been inadequately managed? What do you foresee if we, as a planetary population, do not collectively and uniformly pursue this kind of intelligent administration of the power consumption of the cloud?
Yeah, Steve, it's a difficult question. The doomsday scenario is difficult to imagine. For me, IT usage is quite marginal over the various usage of energy. And we know it's growing, but it's quite marginal. So we can see really that there is a gradient of effort for us that allows us to contribute to this. Like, for example, when we move from private to public cloud, we see already for the same workload, and we did that recently because we moved everything to public, is that we save 5 times the energy when we change the kind of design that we use to be on more modern application. Same thing in the modernization of application. When you switch a design where you use a VM, IaaS architecture, and you switch to container, you can save at least 5 times also, in average, not for a specific application, but on average for all the applications switching architecture. Same thing when you switch from container to serverless using a microkernel architecture and, for example, AWS and Thales. So you see that you can have a direct impact in your tech industry if you build and what is the best of technology if you don't stay in the obsolescence, but you leverage the new tools and the new capacities that AWS is providing, like, for example, new next-gen Graviton architecture and processor. That's really allowing you to generate the same workload with much less energy.
Yeah, actually, maybe I have something to build off of what you were saying, Patrick, which is this efficiency idea around how we consume energy and how we use energy. There's layers to it, right? So obviously, there's data centers that could be running anywhere. There's on-premise data centers, which is like literally sitting in an on-premise environment in an enterprise somewhere. And there's obviously things on the other end of the spectrum, which is AWS. We just did some work with Accenture to kind of understand what's the relative carbon intensity of these things and what kinds of carbon savings might we see or energy savings might we see. It was interesting to do this work with Accenture in part because it was the first time we have used what is now an ISO standard on software carbon intensity. And so there's really, I think, to Patrick's earlier point, a lot of work to try to standardize this space because it is very immature to understand and quantify what's actually happening from an environmental perspective. And so we worked with Accenture on this work, and roughly what we concluded and what you can read in their report is that when we compare optimized workloads on AWS to running them on-prem in kind of a normal on-prem way, it's 4.1 times more energy efficient for a compute workload and up to 2.5 times more energy efficient for a storage workload. And if we translate that to emissions, which includes obviously the energy usage and also the embodied emissions in this research, it can be up to a 99% reduced emission for compute and up to a 93% reduced emissions for the workload for storage. And maybe just to break this out a little bit more, 32% of the reduction for at least one of these scenarios, the US and Canada scenario, that just comes from efficient hardware that came from improved utilization, which is basically like better scheduling in the cloud. And so when we think about kind of the way that we manage the demand growth, there's a lot that can be done from an efficiency perspective. There's a lot that can be gained just by moving things into the cloud where we can take care of a lot of those efficiency values for you. And then on top of that, all of the optimizations that you can do to further reduce your energy consumption or further reduce really your resource consumption, which is the behavior we want to encourage. These really have material impacts. And it really is very much in the decisions we make with suppliers as well as the decisions we make as builders and how we choose hardware, how we build workloads, how we manage load testing so that we scale right, all of these kinds of things. In some have a huge impact. Even if in the little decisions that we make day to day, it doesn't feel like it's that big.
I was going to ask you, if you had any advice for our audience, but I think you've already done that really well, both of you. Is there anything else you would like to add in these closing minutes of the podcast?
if I had to say one thing that really matters to me, it's really I believe in education and sharing knowledge about this issue. So and to promote appropriate behaviors and solutions. So in Thales Digital Identity and Security, for example, we introduced right back in 2021 in our Cloud Academy, which specifically created a track about green IT and Carbon FinOps to explain our view and proposals. At the time, we had to create contents, as most of it was not existing in 2021. And today, the offer are still to be developed. So we continue to add contents regularly. And not only it's a pleasure to contribute to it, but we had fun to discover how to produce content and to participate to it, because there was no existing offer. So it was something new to us. So about your question, I believe it will be very difficult in the future to engage teams without an appropriate posture on this issue. I believe we have a social responsibility by providing good examples, and if we can help by providing an education with a formal on the quality, it will be a good advice for any startup.
I completely agree. And I would also say that although we're early in the process, there are already customers who are doing this and doing it well. We have a number of customers that we've worked with that we have, materially quantified environmental benefits from decisions that they made. For instance, Illumina is a pharmaceutical company. They reduced their emissions by 89% by migrating 50 petabytes of data to AWS and then using intelligent tiering. We have WeTransfer. They took advantage of auto-scaling and then reduced the emissions associated with their server use by 78% in 2022. We have Pinterest. They achieved 38% compute resource savings, so 38% fewer resources, with a 62% carbon savings per query for their use case by moving to Graviton, for instance. And the list goes on. I have like a whole sheet of customers here. Thales is also obviously another great example. But so I think, we can talk about how it's hard to get started, and it is. And it is very difficult, I think. As a builder, you're used to having very granular, very real-time telemetry, and that's just not really possible in the world of sustainability. We're talking about a natural system as opposed to a synthetic system like we're used to dealing with, like with CPU utilization, which we know we can measure, versus carbon emissions, which are harder to measure. And so, although it's difficult, I think, to help builders understand and quantify the impacts associated with their decisions, there's real work being done now, and it's like never been a better time to get started.
Well, it's good to hear that technological growth and power demands and the ecology of the planet can possibly coexist if the will is there and organizations such as AWS and Thales have the vision and the capacity to lead by example. I guess all that remains for me to do is just to thank you both for being here. Margaret O'Toole, worldwide tech leader of sustainability at Amazon Web Services, thank you so much for joining us on the podcast today.
Yeah, thanks. It's been great to chat with you guys.
And Patrick Fulop, Vice President, Cloud Operations at Thales Digital Identity and Security, thank you as well for joining us.
Thank you, Steve, and thank you, Margaret, and thanks to have this nice conversation. And if you need to contact me, I'm visible on the LinkedIn. I will be very passionate about the topic, so I will be glad to answer any question.
Remember, if you like what you hear, be sure to subscribe and tell a friend or a colleague or a client or all of them about the Thales Security Sessions podcast. We will be back again soon with another episode and another discussion on the topics that you need to know about to successfully carry on in the business of information security. Until then, I'm Steve Prentice. Thanks for listening.